Now this video is the continuation of the lime in the eye video. I am showing you the third post lime wash. The patient, the right eye is more severely damaged as compared to the left eye, and you can see again the blanched conjunctiva and hazy cornea, and medially at 3 o'clock limbus there are whitish depositions, so still a chemical was present. You can here see clearly that the chemical is present medially at 3 o'clock, but there is a good thing that conjunctival vessels are present medially, so maybe this patient has not got 360-degree limbal ischemia. So in this video I'll discuss in a detail. First I would like to tell you about the alkalis. Alkalis are present in lime, calcium hydroxide, which is present in whitewash, cement, plaster. Magnesium hydroxide is present in fireworks, crackers. Lye, sodium hydroxide in drain cleaners and airbags. Potassium hydroxide in caustic potash. Ammonia is present in fertilizers, refrigerants, cleaning agents, and baking soda is present in the kitchens. Now acids. Sulfuric acid is present in batteries, and nowadays you know that in every home you will find batteries and in cars as well. Sulfurous acid is present in bleach and refrigerants. Hydrofluoric acid in glass polishing. Acetic acid in vinegar. Hydrochloric acid in swimming pool. So now the question arises that why alkali agents are more dangerous than acids. Well, alkali agents are lipophilic, and that's why they penetrate the cornea and conjunctiva more rapidly than acids. They cause saponification of fatty acids of cell membranes, destroy proteoglycans, the ground substance, and collagen fibers in corneal stroma, damage the tissue like conjunctiva and cornea, and when these tissues are damaged, they secrete proteolytic enzymes which lead to further damage. So the damage of the chemical depends upon following factors: how much time has passed that the chemical is in the eye, how many hours or days, and then how much quantity of chemical has entered the eye, how much area is in contact with the chemical, like the conjunctiva, the limbus 90 degree, 180 degree, 270 degree or 360 degree, and how much deep penetration has occurred, what's the nature of chemical, acid or alkali, and whether strong or weak. So all these factors can tell you how much damage has been done and what's the visual prognosis. So history is very important. Exact time of chemical injury, the composition of material entered, like this patient had whitewash instillation, which is a strong alkali, and almost 20 hours delay occurred when patient presented to me, and the damage in the right eye was profound as compared to the left eye, which showed large amount of material entered the right eye as compared to the left. So when you receive such patient, thorough examination of cornea, conjunctiva, fornices, double eversion of the upper lids to look for chemical particles is necessary. Start irrigation and alongside check pH. Ideally wait 5 minutes after irrigation for a few minutes to check pH to get exact pH value. Degree of damage to the cornea, conjunctiva and limbus should be documented, and that will help in prognosis of final vision. Roper Hall and Dua classification are used to assess limbal ischemia and prognosis. Now in this patient the pH is very high, the temperature of the eye is very high, and we will assess her monthly and wait for the inflammation of the eye to settle. When the eye become quiet, there are chances that vascularization of the cornea will occur, and after 8 to 10 months wait and see whether the cornea recovers or corneal opacification occurs. We will decide the limbal stem cells transplant from the other eye. Now, how to assess a limbal ischemia? Now that is also very important thing. You should know corneal haze, conjunctival blanching, especially at the limbus, will tell you that limbal ischemia is present or not and how much quadrants. You can count it in degrees, like a sphere has got 360 degrees or clock hours. 12 clock hours means 360 degree. Less than 6 clock hours, better is the prognosis. So next question is how to irrigate. Now irrigation should be started at the spot of the injury by friends, family members, or by bystanders to decrease the contact of chemical with the eye. Now it should be continued until the patient reaches the ophthalmologist. So at the spot you can use tap water and irrigate the eye and ask the patient to move his eye and blink frequently, so that water should be spread in the furnaces and the chemical should be diluted as much fast as possible. So remember that irrigation should be started as early as possible and perform as much as possible for neutralization of chemical. At the end, you can apply bandage contact lens or amniotic membrane graft over the cornea to avoid the mechanical friction between the eyelids and the damaged cornea and conjunctiva. You can start artificial tears half hourly. In alkali injuries, intraocular pressure may be raised, so you can give anti-glaucoma. Topical antibiotic and steroid drops should be given 4 times a day. Ointment at night and cycloplegic agent as well to decrease the pain. So I thought I should discuss chemical injury once again in detail. You should know how to look for limbal ischemia. You should know the importance of irrigation in a chemical injury, and you should know which chemicals include acids, which chemicals includes alkali, and how alkali causes damage. So we will follow this patient and I will tell you whether this eye survived or not. Thank you very much.